Okay, so yesterday we refreshed on how to name ions, and we added a new kind with Roman numerals. Last time we did this, we only did ones in group 1A, 2A, and 3A. Now we got some in the B's, and we're going to have to put Roman numerals for those to let us know what their charges are. So we can write the formulas for ions. If they're positive, you have to decide Roman numeral or not. If they're negative, you got to change the ending to IDE. Right? Now we're going to talk about how to write formulas from those names and how to write names from those formulas. Okay? We've done it before with the ones without Roman numerals. So it's not a new skill, we're just adding the Roman numeral piece into it. Okay? And in one direction, it doesn't change at all what you do. In the other direction, it makes it a little bit harder. Okay? So the easy way to go is writing the formulas, because all you got to remember is the charges have to add up to 0. So when you write the formula for an ionic compound, the charges have to add up to 0. So you have to have a positive piece and a negative piece, enough positive to cancel out the negative. So in order to do this, where's touchscreen? There it is. Okay, it's good. All right. In order to do that, first you got to get the charges on the pieces. And the cations, I need positive ions. I'm going to get their charge from either their name, platinum 4. That tells me the charge on platinum is 4+. Or I'm going to be able to get them from the periodic table. If they don't have Roman numerals, I'll be able to find them in group 1A, 2A, or 3A. So I'll be able to get them off the table, or they're going to be in the name. Anions, you'll get from the periodic table for today. Later on, we're going to add polyatomic ions. Okay? We've drawn some structures of them, but we haven't used them in writing names or formulas. We'll add that on Thursday. Thursday, we're going to add that piece to it, the polyatomics. So I just want to let you know they show up. Okay? And then we balance the charges by adding subscripts. However positive it is and however negative it is, I got to make it equal 0. So I got to have the right number of positives and the right number of negatives to make it equal 0. All familiar stuff? This is what we did last semester. It's not changing. The only reason it's going to be changed now is because sometimes we got some Roman numerals, which actually makes our life easier. We don't have to look at the table. So write the formula for calcium chloride. Yeah. Subscripts, the little numbers on the bottom, the 2 in CO2. Sub, below, script, written below. So I got to get the charges on pieces. My first piece is calcium. It doesn't have Roman numerals, so I should be able to find it here on the table. It's in group 2A. So I know the calcium ion is 2+. Because it's in group 2A. Calcium always makes a 2+ ion. Chloride is talking about chlorine when it's negative. And since it's in group 7A, needs one more electron to look like a noble gas. It's 1-. So if I just put Ca2+ and Cl1- together, that's what I thought the formula was for calcium chloride, it wouldn't add up to 0. Because 2+ and 1- adds up to 1+. It's not 0 yet. What would I have to do to make it equal 0? I'd need 2 of the negative pieces, right? I need another Cl-. Because Ca2+ and 2 Cl-, that's 2+, 2-, equals 0. And then when we write the final formula, we leave off the charges. Oops. CaCl2. Familiar? Okay. Here it was easy to figure out there had to be 2 chlorines because the math was easy enough to do in my head. When it gets a little bit more complex, we have a shortcut. You just switch the numerical value of the charges. So if I had Ba2 plus and N3 minus, if I ask, this is me asking you to write the formula for barium nitride. There's a few ways I could do this. I could just start guessing numbers. It would work eventually. Or I could say 2 plus and 3 minus. The positives have to equal the negatives. So where are 2 and 3 going to run into each other? What is the least common multiple? 6. So that's where they're going to run into each other. So whatever it would take to get 6 pluses and 6 negatives. That would work too, right? But the easy way is the crisscross. Take the 2 from Ba and stick it next to N. Don't bring the sign. Take the 3 from N and stick it next to Ba. So I take this number, move it here, that number, just their absolute value, not their charge. And it's just a math trick that's going to make this work. Okay. We've got 3 Ba2 pluses is 6 plus. 2 N3 minuses is 6 minus. My charges are equal and opposite, so they're going to add up to 0. Familiar? Yep, done this before. So the right formula would be, that's the formula for barium nitride. Now, remember the definition for ionic compounds, though, says lowest ratio. So if you've got a 2 and a 4, you'd want to reduce it. Yeah. Because if I don't have that 3 there, it doesn't cancel out. Okay, what I'm writing is Ba2 plus, Ba2 plus, and Ba2 plus. That's what that 3 means. And N3 minus and N3 minus. That's what the, okay. If you say erase the 3, that means I get rid of these. That doesn't equal 0. Doesn't add up to 0. 6 positives have to equal the 6 negatives. So if you take that 2 and move it over, and that 3 and move it over, it'll get you there faster than trying to figure out how do I get to 6 where the 2 and the 3 are going to run into each other. So I can't just drop those numbers. Okay, just try a few. Lithium sulfide. Okay, lithium doesn't have Roman numerals next to it, so I need to know where to look. I find it right at the top of group 1A. So lithium in group 1A always makes a 1 plus charge. Sulfide. We're talking about sulfur when it's negative, and sulfur's in group 6A. 6 minus 8 is negative 2, or 2 more electrons and it would look like argon. Either way, I end up with S with a 2 minus charge. Do those add up to 0? Nope. So if I take this 2 and write it there, and the 1 right there, I don't bother writing 1s. I get Li2S. And that would add up to 0, because Li is 1 plus and 1 plus, and a 2 minus, those cancel out. Okay, let's make it complicated. Let's put a Roman numeral in there. tin 2 oxide. Because lithium has a 1 plus charge. S has a 2 minus charge. In order to equal 0, I'd need two of the things that had 1 plus charges. 1 plus and 1 plus is 2 plus. 2 plus and 2 minus equals 0. Okay. So, tin 2 oxide. So the hard part of this is finding tin on the periodic table. It's number 50. SN. You should know it can't be in group 1A, 2A, or 3A, so you look at the other ones that could be metals. If it wasn't in the transition or inner transitions, it's over there in group 4A. Remember, group 4A needs Roman numerals. So that would be SN. And what does that 2 mean? Does it tell me how many tins there are? No, because that would be an Arabic number. We want it's a Roman numeral. Roman numerals tell me charges. SN's got a 2 plus charge. That's what that 2 means. Roman numerals are charges. And oxide, O, group 6A. 2 more electrons would make it look like a noble gas. Or 6 minus 8 is negative 2, so 2 minus. Does that add up to 0? Yeah, we're done then. Some of you might be tempted to do the crisscross here. If you did the crisscross, you'd get SN2, O2. Can you reduce that? Yeah, and you get SNO. So the crisscross works as long as you reduce. That makes sense? And we need to reduce so we only have one equation for every chemical. Otherwise, there'd be an infinite number of SNOs. I'd have SNO2, SN2O2, SN3O3, SN4O4. We don't want that. We want the lowest ratio. They're all just SNOs that repeat. Because remember, that's what ionic compound is a repeating units. Yeah? So that's what you do with the Roman numerals. Hugely different? Nah. Well, tin, the reason why we need Roman numerals for tin is tin also makes another ion. Sometimes it makes the tin 4 ion. And I know that's a 4 because it's before, the I's before the O, or the I's before the V. So tin is still SN. Now it has a 4 plus charge. Oxide is still O. Oxide still has a 2 minus charge. Oxygen always gets the same charge. Always gains 2 electrons. Does that add up to 0? No. So I do the crisscross and I get SN 2 O 4. Is that the lowest ratio? No. So I reduce it. I get SnO2, and SnO2 still adds up to 0. Because Sn is 4 plus, O is 2 minus, and there's 2 of them. Okay. Or I could think of, it doesn't equal 0. What's the least common multiple of 2 and 4? 4. Right? Okay, so if it's 4, then I got to make my charges 4. 4 plus and 4 minus. That's the other way you can look at it. Iron 3 phosphide. Well, iron is Fe. Periodic table tells me nothing about charge. But they told me the charge. They wrote it there, right? That charge is a 3 plus. Phosphide, P, group 5A. 5 minus 8 is negative 3. Or 1, 2, 3 more electrons to look like a noble gas. Either way, I get that phosphide has a 3 minus charge. Does that add up to 0? Yeah. So we're done. FEP. Like right now. There we go. FEP. What about iron 2 sulfide? sorry, iron 3 sulfide. Sorry, iron 3. So it's still iron 3. Iron 3 sulfide. Look at my Roman numerals. Iron 3 sulfide. Iron 3 plus. Back on number 1, we already did sulfide, but then what we did was we looked it up and said, hey, sulfur is a group 6A. 6A always makes a 2- ion. Does that add up to 0? No. So you do the crisscross and you get Fe2S3. So the only thing different from what we did last time is we can use Roman numerals. Okay? So, and going this way, Roman numerals actually make it pretty easy. They tell me the charges. The only temptation people have is they think the Roman numeral means how many. It's not how many, it's the charges. Okay, going the other way is a little bit more difficult, but it's the same math, only backwards. So we say binary, we're talking about the ones made up of only 2 elements. When we add polyatomic ions, we'll have some that are made up of 3 elements. Ionic means a cation and anion. And the name? The name is just the name of the ions. Just write the name of the ions. So we don't have twice as many names. We've got to pick an order. It's always cation first, anion second. Just like in the formulas, cation first, anion second. Metal first, non-metal second. Positive piece first, negative piece second. Depends on how you want to look at it. They're all ways of saying the same thing. And we've done this before. And it was pretty easy with the group A elements, because with the group A elements, you don't have to worry about Roman numerals. So NaCl. Na is the sodium ion. Cl is the chloride ion. So the name of the chemical is sodium chloride, made up of sodium ions and chloride ions. Wow, that's awful, isn't it? It's actually just writing the names of the ions next to each other. So it's not a new skill. It's the same one we had. Now, some people are confused by this, but let's make clear that MgBr2 is called magnesium bromide, that you don't mention the 2 at all. The name does not include the 2. Mg, the ion Mg makes, is the magnesium ion. Br, the ion Br makes, is the bromide ion. So the name of this is magnesium bromide. Why don't they tell me about the 2? Why isn't that 2 in the name someplace? Well, because chemists are lazy. And they don't want to write any more than they absolutely have to. And every time you put magnesium and bromine together, there's going to be 2 bromines, because the charges have to add up to 0. What we just did a second ago, was that hard to do? Was it hard to figure out how many of each piece? So if it's easy to figure out, it does not show up in the name. Does that make sense? How short can we write this name and include all the information we need? If somebody tells you magnesium bromide, that's enough to write MgBr2. And since it's enough, that's all we're writing. Come back to what's the minimum information we can give you where everybody will get the same formula. Make sense? So what would you write for the name of Na2S? Well, what's the name of the ion that sodium makes? It's called the sodium ion. So the first word is sodium. What's the name for the ion S makes? S is sulfur, but it's an ion. We call it, it's negative, so we call it sulfide. Really easy. Just write the names of the ions. Don't have to figure out a Roman numeral because they were in the columns where I didn't need a Roman numeral. And that's the challenge. What do you do with those transition metals? Because when I write their name, I have to put the charge of the cation in the middle of their name. I can't just say iron chloride. I have to say which iron. Sometimes iron's 2+, sometimes iron's 3+. And in the name, I have to tell you which one it is because you can't get it anyplace else. So what are we going to do with the name? Well, we got to put the charge in. That means I have to figure out the charge. Okay? So I got to figure out what the positive charge is. How am I going to do that? Well, the compound has to add to 0. The compound has to be neutral. The compound has to have the same number of positive and negative charges. Isn't that what we just worked on a second ago? So if I give you a formula and it starts off with iron, you need to figure out the charge on iron. Well, the key is that formula adds up to 0. And I always know the negative charge. Never had any problems with the negative charges. It's just positive charges we sometimes have to figure out, right? So I use the negative charge to figure out what the positive charge has to be. And then I take into account how many atoms I have to make that charge. So if I need a positive charge of 2, and I've got 2 atoms, each atom has a 1+ charge. If I need a positive charge of 4, and each atom has a charge of 2, I need 2 of them. Figure out how many of those pieces you need to get it to equal 0. So it's pretty simple math. Figure out the total negative. That's going to equal your total positive. Figure out how big each one if that's the total. So let's try a few. Write the name of CuO. Cu is copper. Copper is a transition metal. So I know my first word is going to be copper, but copper needs a Roman numeral. So before I can write that Roman numeral for copper, I got to figure out what the charge is on copper. Well, I know that O is 2 negative. O always makes a 2 negative. It's in group 6A. Oxygen family always makes 2 negative charges. So it's the charge on Cu. Yeah, if O is 2 negative, Cu has to be 2 positive. It's going to add up to 0. So copper has to be 2+. That's the only way it's going to add up to 0. So that means the charge on copper is 2. So the name of the ion is copper 2. And then the second half is oxygen, but I changed that to ide. So this is copper 2 oxide. Charges have to add up to 0. Okay? That one's really easy because neither one of them had a subscript. What do you do when they have subscripts? Like COCl3. CO is cobalt. So my first word is going to be cobalt, and cobalt needs Roman numerals. Think of this, the A things, parentheses around here to remind you. Those things all need Roman numerals. Okay. All right, so it's cobalt something, and then Cl is chlorine. We're going to change that to chloride. So it's cobalt something chloride. I got to figure out the something. Well, I know that Cl is 1 negative. Halogens always get a 1 negative charge. And there are 3 Cls. So that gives me a total negative charge of 3 negative. So each Cl is 1 negative, but my total is 3 negative. So my total positive has to be 3 positive. I've got 1 cobalt. What's its charge if the total has to be 3 positive? 3 positive. So CO has to be 3 plus. So now we know the Roman numeral. It's cobalt 3 chloride. So if there's a coefficient on the negative piece, you have to multiply by how many negative pieces you have to figure out what the total negative is, so you know what the total positive is. What if the subscript is on the metal you're trying to find? Yeah. Okay. So write the name of copper blank, and S is sulfur, so we change that to sulfide. So we know it's copper blank sulfide. We just got to fill in the blank. So I need the charge on copper. Well, S is 2 minus. It's group 6A. So S is 2 minus, so my total negative is 2 negative. My total positive has to be 2 positive. So I put my totals at the bottom. I've got 2 coppers that add up to 2 positive. How big is each copper? Each copper has to be 1 plus. And that's the Roman numeral I use. So that's going to be copper 1 sulfide. Now if you go back in your notes, you might be a little confused because copper 1 sulfide has a 2 in it, but copper 2 oxide didn't have any 2's in it. The 2's in the name are about charges, not about how many. We can use it to figure out how many, but it's not how many. Does that make sense? And now for the rust of the story. This is rust, Fe2O3. Fe is iron, so I know I'm going to write iron. Iron's in the middle of transition metals, so I need parentheses. O is oxygen. I'm going to change that to oxide, so it's iron something oxide. I need to figure out what the something is. Each O is 2 negative. So if each O is 2 negative, and there's 3 of them, I got a total of 6 negative. That means I need a total of 6 positive. Because 6 positive and 6 negative adds up to 0. I've got 2 irons that have to add up to 6 positive. How big is each iron? What plus what equals 6? It's got to be 3 plus. And I can't even write it there. It erases it on me. It should be 3 plus. Yeah. And so the name of this is iron 3 oxide. So this is the hard way. And it's not that hard. The mistake people make is not figuring it out. It's forgetting to write it. So first decision, does it need a Roman numeral? Make sense? So let's try a few more, and then we'll set you off for your homework. What would the name of KCl be? Okay. First, I find K on the table for two reasons. One, to figure out its name. Second, to figure out, do I need Roman numerals? K is here. Does K need Roman numerals? Nah. Its name is potassium. So K is the potassium ion. Cl. Chlorine, I changed to chloride. Yeah. No. Red? Noble gases don't react. Noble gases over here, these don't react, so you're not gonna react those. Okay. Oxygen looks like a noble gas when it's gained 2 electrons. Chlorine looks like a noble gas when it's gained 1 electron. We haven't used any of the noble gases, and we won't for the most part, because noble gases have noble gas configurations, so they don't want to change. Oh, everything that's negative gets I'd. All the nonmetals, all the ones that are second. Anytime you take an element off so all the ones that are negative, -3, -2, -1, all of those get changed to I'd. What about Na3N? Okay, so Na. Does Na need Roman numerals? Nope. Its name is sodium. It's the sodium ion. N, non-metal. Nitrogen, just shorten it and put the "ide" on, so that would be nitride. So I write sodium nitride. What do I do about the 3? Nothing. I don't need to mention it, because if I go backwards, I'd say sodium is 1 plus, N's 3 minus. That doesn't add up to 0, so I'll do the crisscross. And I'll get Na3N. I'll get the same answer. So if it's easy to figure out, it doesn't show up in the name. What about CRN? Well, Cr is chromium. So I know my first word's got to be chromium. I don't change the metal. Does chromium need Roman numerals? Yes, so I got to figure out what they are. N is nitrogen, so it's still going to be nitride. Well, figure out the Roman numeral. I know nitrogen is a 3 minus ion. There's only one of them. So what does the charge on Cr have to be? Or it equals 0. It's got to be 3 plus, and that's what goes in there as my Roman numeral. So it's chromium 3 nitride. Make sense? What about Sc3P2? Sc is scandium. Does scandium need Roman numerals? Is it in 1A, 2A, or 3A? No, it's not in 1A, 2A, or 3A. 1A, 2A, 3A. It's a transition metal. It needs Roman numerals. P is phosphorus. We change that to one syllable in "ide," so that's going to be phosphide. P is 3 negative. So my total negative is 6 negative. So my total positive has to be 6 positive. I've got 3 scandiums that add up to 6 positive. How big is each scandium? 2. And that's the number I put there. Doable? So the hardest part is figuring out the Roman numerals. So that's where I wanted to go there. So have you practice doing that. And like I say, what we're going to do on Thursday is we're going to add polyatomic ions to this, which is groups of ions. Write their names and formulas. That's what our next piece is. You'll read about those as you do the reading guide. You have 2 days worth of homework because I don't get to see you for a couple of days.